Hello, welcome to another class again. Today we are going to be dealing on percentage composition. When we talk about percentage composition, you are talking about the amount in percentage of a particular element as contained in one mole of a compound. As we see, we have different compound there. We have CH3COH, which is ethanoic acid. We have H2SO4, tetraoxosulfosic acid. We have KClO3, triosochlorified salt, and then we have NaOH, which is sodium hydroxide. So these are the various relative atomic masses of each of the elements. And we are going to calculate their relative, their percentage composition in each of these compounds. Now, how do we do that? Let's take the first example, number one, CH3COOH. The question says we should calculate the percentage composition of oxygen in each of these elements. So what we are going to do first of all is to find the total molar mass, rather the total mass or the molar mass of these elements, of this compound, sorry. That's what we are going to calculate first. So let's calculate the molar mass. Just like if you check my previous video, you see I have already very demonstrated how to calculate molar mass. I'm going to do that here again. That's C plus 3H plus C plus 2O plus H. That's what is these are the components of each of these. So you have 12 plus 3 times 1 plus 12 plus 2 times 16 plus 1. So when you add up everything, you have 12 plus 3 plus 12 plus 2 times 16 give us 32 plus 1. This will give us 15. This will give us 15 plus 12, 27 plus 33, which eventually you are going to have is 15 plus 12. Let me recalculate to ensure I'm correct. Okay, that's 20 plus this 33. So you are having 60 gram per mole. Now that's the entire mass of the compound of ethanoic acid. You can look at it and see if we are correct. It's 24, 27. It's 32. Was that 3? So we are correct. So now to get the percentage composition of oxygen, take note we have 2 atoms of oxygen in the compound. So we must take note. So the formula is percentage composition is equal to the mass of oxygen over the total mass of the compound times 100%. That's the mass of the element in question, which we are dealing with, oxygen, over the total mass of the compound times 100%. So what are we going to have? Now, take note, the mass of oxygen is the amount of in this particular compound, we have 2 oxygen. So we must make reference to that as 2 times 16 over 60 times 100%, of which you are going to have 32 over 60 times 100%. If you do this one very well, you are going to have 320 over 6%, which if you calculate it, you're definitely going to have something relating to 50. Or no, not just 50. We have this one will give us 3. That's 53.33%. You can punch your calculator and get that very well, and then you'll be able to see that the percentage composition of oxygen in this compound is 53.33%. Thank you. But let's take one more example, then you take care of the rest one, you do the other. So one more example, let's do the that of so I'm going to do KClO3. So that's KClO3. So calculating this one, you have K plus Cl plus 3O, so which is 39 plus 35.5 plus 3 times 16. So you have 74.5 plus 48, which will give you 122.5 gram per mole. This is the total mass of KClO3. Now to get the percentage composition of oxygen will now be equal to the 3 oxygen that we have in that question. 3 oxygen over the total over KClO3 times 100%. So what are we having here? 3, that's 48 as we have calculated here, which is 3 times 16 over 122.5 times 100%. When you do this one very well, you're going to have 4,800 over 122.5, and then whatever you have there will give you your answer in 2 decimal place. Don't forget that. So you can try your hands on others like on H2SO4 and NOH. Calculate the percentage composition of oxygen in each of these elements. And if you have any challenge, feel free to reach out to me, and also subscribe to my YouTube channel and every channel that you see me teach. Thank you very much. Bye.